Wind is a great source of clean, renewable power, yet in their current form, the vast majority of wind turbines cannot be considered fully sustainable. The problem lies with the blades, made out of composite materials that are extremely difficult and costly to recycle, which means that at the end of their useful life, the blades end up in landfills. That is very unfortunate, because what's the point of clean energy if it generates more waste and pollution? We should re-evaluate current strategies, and I make a case that we should make the turbines smaller, built locally and out of wood. According to some reports, humans have been harnessing the power of wind at least since the 17th century BC to irrigate the gardens in Babylon under the rule of King Hammurabi. The oldest remaining active windmills are so-called asbads and are spread over Iran and Afghanistan. Developed in the 9th or 10th century AD, academics of the time report that these mills were used for grinding grains and pumping water out of wells. Contrary to modern windmills, the wind pushed the blades around in a vertical axis. Over the years, windmills were substantially developed, and their number reached a peak in the 19th century, when there were hundreds of thousands of windmills in operation across the globe. Whether it was for pumping, milling, draining, transport over water or land, or even heating, people have always found creative ways to use locally available resource to harvest the power of wind. Whether made from wood, stone, brick, canvas or metal, where there's wind, there's a way. Ancient windmills all have one simple thing in common. They were made using only natural materials. The blades or sails were usually made of a wooden framework, covered with canvas or wooden boards. They were used for all kinds of purposes, but using windmills for generating electricity is a fairly novel application. The first electricity-producing models appeared in the late 19th century, and we have come a long way since. Scottish electrical engineer James Blyth is credited with having the first known structure by which electricity was generated from wind, back in 1887. The electricity was used to power 10 25-volt bulbs in his holiday home, needing only a moderate breeze. Blyth allegedly offered to use the electricity surplus for providing the village with electric streetlights, but was turned down by the villagers who viewed the electricity as
the work of the devil.
Blyth later built a turbine at a Montrose lunatic asylum, which supplied it with emergency power. The turbine operated successfully for 30 years. With parallel developments in the United States and in Europe, the predecessors of our modern turbines find their roots in Denmark. In 1891, Paul Lacour, a Danish scientist and inventor, constructed a horizontal axis wind turbine with an astonishing 18 kilowatt rating in Askov, Jutland. Later models were capable to generate up to 35 kilowatts. The design spread rapidly, and in the early 20th century, thousands of farms in Denmark were wind-powered. Most people built their own turbines to take advantage of the strong winds. In the following decades, with cheap power from fossil fuels, interest died down and many windmills became inoperational. A renewed interest only came with the oil crisis of the 1970s, and in the subsequent decades a so-called wind revival took place. This was also a time of experimentation and innovation. Some wind turbine models produced heat directly instead of electricity, like a giant Joule machine. The design used a water break placed inside the bottom of the tower. An insulated round tank was kept under a small roof, and inside the house, a 20,000-liter water tank accumulated the heat produced by the turbine, supplying the house year-round with home and water heating. Turbines gradually evolved into today's three-bladed design with upwind rotors, which is still steadily increasing in size. Today, wind turbines, together with photovoltaics, are the main technologies in terms of new electricity generation by capacity. Most people are familiar with the contemporary wind turbines, very tall, often placed in groups, towering high above the surrounding landscape. It seems that every year another record is broken: tallest base, most energy generated, longest blade, and so forth.
Sheesh, that's crazy!
Given that the size-to-power ratio is not linear, because the higher and larger a turbine is, the more power it can generate, bigger is not necessarily better, and in fact windmills have not always been mastodons, nor do they need to be. Turbines only became so large because they became part of a strategy to feed national grids. This led to so-called wind farms in remote locations, such as deserts or offshore at sea. The power generated at these farms is far from where it's needed, requiring additional infrastructure to transmit the electricity. These efforts are laudable in many ways. Wind energy is an amazing source of clean energy, and we absolutely should be using it. But by shifting to ever larger turbines, we are offsetting some of the ecological benefits by creating enormous quantities of non-recyclable waste and harming fauna and flora around them. So, what are the issues with modern turbines that make them less sustainable? First, bigger turbines simply require more material. Beside the increased quantities of raw materials, blade quality must also increase. The larger the blade, the more forces they are subject to, causing it to bend. This means that blade stiffness is key to maintaining optimal aerodynamic performance and to avoid hitting the tower and catastrophically self-destruct. Besides being very strong, the blades must also be as light as possible. This engineering challenge is solved by using composites made mostly out of a combination of epoxy, a petroleum-derived product, with fiberglass or sometimes carbon fiber reinforcements. The blades also contain sandwiched core materials such as polyvinyl chloride foam, polyethylene terephthalate foam, wood, and polyurethane coatings. The majority of these materials are not biodegradable and consists of very fine strands of plastic and glass, exactly what makes recycling so difficult. It is currently not cost-effective to recycle them. Instead, most decommissioned blades are discarded in landfills or incinerated. For example, a blade measuring 50 meters in length can reach between 12 to 15 tons in weight, with larger blades reaching over 70 tons per blade. That's a lot of composite waste. There are some creative attempts to reuse blades as bike sheds, playgrounds, or even glamping pods. But this cannot be realistically done for the millions of blades that we will have to deal with at some point in the future. The only part of wind turbines that is readily recyclable is the steel mast, along with some minor components and cables. Since the mast is the principal part, companies can claim figures such as 85% recyclable.
Wow.
Still, considering how much plastic ends up in the ground, there is reason for serious concern, especially as turbine numbers keep increasing. Even companies developing recyclable blades still use composite materials, meaning separation is required to recycle. This can be done using acids or chemicals, not cheap and certainly not ecological. While this looks like progress, it remains too complicated. Contrary to modern wind turbines, which need to be replaced regularly and in their entirety, old-fashioned windmills could last for many decades or even centuries with regular repair and maintenance. Second, beside requiring more resources, colossal turbines change landscapes, dominating the horizon and drawing attention to themselves. They also cast disturbing moving shadows when built near homes. Imagine having to deal with this type of nuisance every time the sun is out.
Who could ever imagine this? No, you couldn't imagine this. I voted to be green. I'm not against green power. I voted to be green, but I never thought this is what it would mean to be green.
As is clear from this clip, opposing windmills does not mean opposing green energy. Smaller turbines would not create this flickering effect on this household while keeping the power generation locally. Furthermore, larger turbines also kill more birds. To be fair, wind turbines are responsible for a minuscule share of total bird deaths. In fact, any tall structure can potentially be fatal to birds. Large skyscrapers with glass windows or communication towers are more likely to be fatal to birds. Nevertheless, smaller turbines save bird lives. Bird lives matter. While one could argue that the numbers of birds dying by wind turbines is small compared to other causes of death, that argument still shows a short-sightedness and lack of respect for life, considering the killing of birds as a necessary sacrifice in order to combat climate change. An ideal solution cares for all life. As you can probably understand by now, wind power is not the problem, far from it. The problem is the trend for larger and centralized units. One way to reduce many of these side effects is to go back to building smaller windmills, made from local materials and ideally out of wood. Why wood? Well, trees can be grown locally, are a relatively cheap resource and are a carbon sink. The carbon dioxide absorbed by the trees will not return to the atmosphere for as long as the windmill is in use. Want to beat 85% recyclable? How about 100% recyclable carbon-negative renewable energy? Ahead of sustainability's wet dream. Think about the LinkedIn cred. Advances in technology and design now make it possible to build larger wind turbines almost entirely out of wood. Swedish company Modvion is at the forefront, demonstrating that it's possible to go big with wood. The laminated veneer lumber in their wooden tower has higher strength per weight and higher strength per cost than the steel alternatives. It turns out that wood is actually incredible for building very tall structures, and the benefits in comparison to steel become more relevant as height increases. Using wood would also solve recycling issues and make the manufacturing of wind turbines largely independent of fossil fuels and other mined materials. Well-managed forests located close to the turbines could provide raw materials for the next generations of wind turbines. Forest growth is rebounding in 2025, according to the Swedish National Forest Inventory, meaning that the net amount of wood is increasing, despite the felling of trees. According to some calculations, it only takes an average of 5 to 10 minutes to grow a wind turbine in Sweden's forests. Not just the base, but also the blades can be made out of laminated or regular wood. Although the strength and stiffness are lower compared to composite materials, much of the load that the blade must support is a consequence of its own weight. So a wooden blade doesn't need to be as strong as a fiberglass blade. Nevertheless, the low stiffness of wood still makes it challenging to use wooden blades for very large turbines. Despite fully wooden turbines being an excellent evolution, there are still drawbacks to the technology, and a case can be made for smaller turbines. They suit small-scale farms, factories, and communities. Plus, they can be carved out of solid wood and made locally. Many designs exist, and projects around the world aim to spread this technology. Companies like Innoventum or EAZ Wind are at the forefront of this movement. EAZ, a company established in the Netherlands by 4 engineers, now taken over by Ecoways, developed their own model of turbines made out of wood. They have installed them mostly at farms, but also in residential areas where costs are shared between households. Their next customers are often neighbors. Unlike big turbines, where neighbors are usually the first to protest, farms and villages would benefit enormously from small-scale wind. Most people do not want a mastodontic turbine nearby, but a small one is more acceptable. Less noise, fewer shadows, less visual impact. Instead of a few giant turbines feeding distant grids, you get many small turbines built right where the energy is to be consumed. They offer energy independence, can be installed in days, and according to users of certain models, average payback time is 6 to 8 years, depending on their usage, of course. They blend better into the landscapes, kill fewer birds, and are systems that people can understand, repair, or even build themselves. Wind energy stays clean, but by making it smaller, it becomes human again. There is no doubt that today wind turbines have become more efficient at producing energy than ever, but they also have become less sustainable. By giving up some of that efficiency, we could make them more sustainable again. On paper, it might not seem like the best option if you put monetary value on everything. Many benefits are not quantifiable. From a purely economic perspective, it may seem strange to argue for smaller systems, but the same logic applies to cars, farms, or even governments. Impact is local. Building resilience with systems people understand, own, and repair makes life much simpler, more human, and more sustainable. This is a trend I believe will shape the future, making everything smaller. Windmills, cars, farms, government. Take back the power. Power to us. Thank you so much for watching this video. I hope you enjoyed it. If you have any questions, let me know in the comments. Otherwise, leave a like, subscribe, and I will see you in the next video. Bye.